In this lesson there is a motivation and introduction to the course of extremes indicating that apart from the cases of natural disasters and accidents, extremes always appear in the design of engineering works of all types. We hope the reader to be aware of the importance of knowing how these extremes behave, and that this is very different from the case of mean values, more common in most uses of statistics. To prevent the reader from the need to change the statistical paradigm, if he or she comes from the usual statistical practice, a small example is used at the end, which aims to highlight the importance of thinking in extremes, that is, to incorporate the new statistical paradigm that is necessary in the usual practice of engineering. We start the series of examples with the case of waves, which are undoubtedly the most important action to consider in coastal and marine works. This photo has been manipulated, exaggerating the size of the waves, to show that we must be very careful with them, since they are the main causes of many failures of coastal and marine structures. An important example of a natural disaster is the case of tsunamis, who cause very important damage to society, as shown in this photograph, which corresponds to the one that took place in Banda Aceh in Indonesia, in 2005. The waves produced by tsunamis, like those shown in the figure, are large and are produced by seismic movements. Their prediction and immediate knowledge are crucial to reduce the damage produced, especially of human and animal lives. Another of the most important natural disasters are those produced by floods, originated by extreme rains or large amounts of rain in a very short time. The figure and the text illustrate the magnitude of the damage and in what and why it is important to know when they occur and where. The photo corresponds to the Kashi River in India. Other major natural disasters are those caused by tornadoes. The figure shows some of them in full action and the magnitude of their consequences. Next, we show how extremes arise naturally in engineering. Apart from disasters, extremes always appear in engineering. In fact, engineering design is always based on maxima, loads, winds, earthquakes, snowfall, pollution levels, radioactivity levels, etc., and minima, strengths, droughts, lack of water supply, etc., because they are the main causes of failures. In other words, engineers cannot avoid to deal with extremes. Thus, knowledge of how to do it is essential to engineering work. The knowledge of the maximum wave heights that will occur in a certain area, and the corresponding periods, are necessary to design and size the breakwater dikes and the protection works of all kinds on our coasts. The random nature of these complicates this work considerably. The figure allows us to imagine the damage that a storm can produce, while showing us the importance of being able to measure the size of the waves and their associated probabilities. Next, we show the importance of extremes in structural engineering. Normally, the failures of structures take place due to very high loadings, that is, large loads, earthquakes, winds, snowfall, etc., but also due to materials or elements of them with a small resistance. Therefore, both extremes, maxima and minima, are relevant in engineering. Following is a graphic example of the importance of slope stability. The figure shows the slippage of a slope that produces the failure of a railway line and the possibility of a very severe accident, because normally the passage of the train is the one that produces the worst case, because to the existing loads we must add its weight. In summary, the field of extremes, maxima, and minima of random variables has attracted the attention of engineers, scientists, and statisticians for many years, because engineering works need to be designed for extreme conditions. In some statistical applications, the interest is centered on estimating some population central characteristics, for example, the mean rainfall, the average temperature, the median income, etc. Contrary, in most areas of applications, engineers are interested in estimating the maximum, the minimum, or the high or low order statistics. However, the statistical theory for dealing with mean values is very different from the statistical theory required for extremes, so that one cannot solve the above indicated problems without a specialized knowledge on the statistical theory of extremes. A common statistician tends to think mainly of mean values. An extreme value statistician has a different point of view, and usually thinks of maxima or minima. It is not easy to change the mind to become an extreme value statistician. In some cases it is better to start from scratch. To illustrate, we invite the reader to read the words in the 2 lines below, with a series of colors, from left to right and top to bottom. You will see that it does not cost much. Next, we invite you to say the colors in which the words of the following 2 lines are written. You will notice that it is much more difficult. The reason is that we are used to reading words and not colors, so we have difficulty in changing paradigms. The same difficulty will be experienced by the reader who comes from a standard use of statistics, when faced with a statistic of extreme values. With this experience we end this lesson, in which we expect the reader to understand that engineering design is mainly based on extremes and that this is the main reason to study the behavior of extreme values.